Dear students, welcome to this lecture. Today's topic is process migration. Process migration. So, before seeing the process management concepts in distributed operating system, let us know what is the mechanism used in centralized operating system. You know that in a centralized operating system, there will be different mechanisms and policies for sharing the processor of the system. Why? Because that centralized processor should be shared among all the processes. But here in a distributed operating system, multiple processors can be shared among all the processes. Multiple processors can be shared among different processes in a system, so that this process management will lead to a best possible use of the processing resources. Means we can use all the processing resources in an efficient manner with the help of this process management. Out of these, so there are three important concepts that are used in distributed operating system for achieving the process management goal. That is processor allocation and processor migration threads. So these are the three concepts. So this processor allocation has already been described in our previous lectures. Okay. What this processor allocation will deal with is the process of deciding which process should be assigned to which processor. All these we have discussed in our previous lectures, and I hope by following different methods like that serial assignment, optimal assignment, load sharing, load balancing approaches, where in that we have did this process allocation only. Now we will see here in terms of process management in these two concepts. So these two concepts are process migration. Means it deals with the movement of a process from its current location to the processor. If the current process is P1 need to be moved to processor N2, then how that migration, how that movement will be done from current location to the assigned process. Assigned is N2. Okay, like that, how the process migration, moving from one node to another, or moving the process from its current location to the processor to which it has been assigned. To which node it has been assigned, it should go up to this in order to execute that process. That is process migration. And the next is threads. Threads are nothing but which enables to run in a parallel manner. Means one process will be divided into multiple tasks called as threads, and those threads will run in parallel so that for better utilization of the processing capability will be there when you are using threads. We will see these two concepts in detail now. So in the process migration, we have already said that process migration is the relocation of the process from its current node to the destination node. What is the current node? So in the source node, the process P1 is in execution. So it is executing, and after some time the execution is suspended and the transfer of control is given, and the destination node will start the execution of this P1 process from the statement which has been it was suspended. Say for example it has suspended at 20th line, then the execution will resume from the 20th line of the P1 process, and further P1 process execution will be done in this destination node. Whatever time here it is there for transfer of control is nothing but the freezing time. Means we are freezing the process in that particular time. Otherwise, the instructions will be going on in nodes. So we need to freeze that process and execution suspended. Then we will transfer the P1 process to the destination node. This is nothing but the relocation of a process from current location to the another node, that is destination node, is called as process migration. The flow of execution is like this. So see here, a process can be migrated either before it starts its execution or during the course of the execution. Means before starting this P1 process only, we can transfer it to the destination node, or after executing the process for some time, then in such a case, during the course of its execution, means during its execution time, in between or before completion of that execution, also we can migrate the process. So if we migrate that process, in the former case is known as non-primitive process migration. Means before starting the execution only we are moving, and the latter case means in which we can disturb in after starting the execution, that is primitive process migration. So this primitive process migration is costlier. Why? Because we have to suspend that process, freeze that process, and then we have to transfer the control to the destination node. Like that, it is costlier than non-primitive process migration. See here, since the process environment must also accompany the process to its new node for already executing process. Means if this destination node also have this capacity to run that particular process along with the already process running in the destination node. So it is somewhat costlier. Means moving the process in between the execution, that is primitive process, is somewhat costlier. Primitive migration. Next, process migration involves these major steps. Those are selection of a process that should be migrated, means which process should be migrated, we need to select that process, and the selection of the destination node to which the selected process should be migrated. Second thing is, first one is which process to be migrated, and second one is to which node it should be migrated. After selection, if you have assumed that P1 should be migrated to which destination node, suppose N5. N5 is the destination. So, what like that we need to select the destination node to migrate this process. And the third one is actual transfer of the selected process to the destination node. After selection of destination node, the third step is this one. We need to migrate it from the source node to destination node. So we will see the desirable features of a good process migration mechanism. Means up to now, I hope you understood that what is meant by process migration. moving from one source node to another destination node is process migration. We can do it in a primitive basis or in a non-primitive basis. And the other thing is, what are the desirable features? With what features this process migration mechanism will be going in a smooth way means if it is having transparency. Means we have already seen about transparency in a distributed system. Here the transparency is one of the requirements of the system in order to support the process migration. This process migration transparency will be of two types: object access level transparency and system call and inter-process communication level. Okay, transparency in object access level. So in this type of transparency, it is a minimum requirement for a system to support non-primitive migration facility. Means if we want to assume a non-primitive process migration facility, this feature must be there in a system. So in this level, the process can access to objects such as files and devices, and this object level transparency will allow the free running of programs at any arbitrary node, at any node. Okay, that's about object access level, which is minimum requirement of the system to support the non-primitive process. And the second one in the terms of transparency is system call and inter-process communication. Transparency in system call and inter-process communication level is when a process is migrated, that migrated process should not depend upon its originating node after being migrated. Means all the necessary system calls and the inter-process communication should be location independent. This level of transparency must be provided in the system in order to support the primitive process migration facility. Means it is nothing but that if that P1 process is originating from node N1 and it is transferred to node N5, in such a case, further P1 process should not depend upon the system calls of N1. That the independent nature of location is nothing but the transparency, and this transparency must be achieved and it is supported for all the primitive process migration facilities. This transparency of inter-process communication is also one of the desired feature for the transparent redirection of the messages. Okay, so transparency is object level or the system call and inter-process communication. User should not know whether it is a local process or a remote process. That is the transparency we need to achieve in a distributed system. Like that, here also it should be independent of that particular location, and all the system calls also independent of that migrated process from the originating node. And the second is minimal interference. What is this minimal interference? Means minimal means low, interferences, disturbances, or whatever we will move the progress of the process in a minimum with minimum disturbance, with minimum interference. So that So that one is, while migrating the process, it should cause the minimal interference to the progress of the process. Means when we are downloading something, if internet is low, in such a case, it will download slowly. But after improving the internet, it will suddenly download as fast. Means there is a minimum interference in downloading. Like that, while migrating the process also, the progress of that process should have the minimal interference. That process execution progress can be disturbed for some time. So one of the method to achieve this is we are using, I have shown the freezing time. So this method will freeze the process. This freezing time is nothing but the time period for which the execution of a process is stopped for transferring the information to the destination node. So with this, minimal interference can be solved. Okay. So to provide minimal interference, we are using freezing time to minimize the time of interference. And the next is minimal residue dependencies. Residue is nothing but out of the whole, if a small part is left over, it is called as residue. So minimal residue dependencies means this minimal dependency also should not be there in the previous node. Means if a migrated process is there, it should not in any way continue to depend upon its previous node. It is migrated to new node. Further, it should not depend its small part of execution on the previous node. Okay. Once it has started its execution in the new node, it should continue. Otherwise, what happens? Some part is running in node previous node, and the another one is running in the new node, which will decrease the benefits of migrating the process. And sometimes there might be a failure or reboot of the previous node, which will cause the process to fail also. So there should be minimal residue dependencies. And the next feature is efficiency. This is one of the major issues in implementing process migration, and the main sources of inefficiency involved with process migration are the time required for migrating a process and the cost of locating an object, the cost of supporting remote execution once the process is migrated. So all these costs should be kept minimum in order to achieve the efficiency. Whatever time required for migrating process should be less. Cost of locating an object should be less, and the cost of supporting that remote execution is also considered. So if when all these are minimum, then automatically efficiency will be achieved. And the next feature is robustness. Means robustness is a feature in the sense that any failure of a node is occurred, in such a case, a process that is currently running should not in any way affect the execution of the process. Means it should run, the process which is running on that particular node should run even under any failures. Care should be taken in such a manner. And the last feature is communication between co-processes of a job. What is this means? It is the parallel processing job among the different processes. One single job is distributed over several nodes. So if this facility is supported, which means there is a communication between co-processes, then it can reduce some communication costs, and it is also necessary in order to communicate between the co-processes. So these are the desirable features of a good migration mechanism. Okay. So minimal interferences, freezing time of the process being migrated, residuals in terms of failure or reboot of the previous nodes, it should run, efficiency, robustness, and even in the failure of a node, in such a case also process should be currently running, that is robustness communication. And the next topic is process migration mechanism. Up to now we have seen what is meant by process migration, what are the features that are important for process migration, and now what are the mechanisms, what are the methods which are there in process migration. So always the migration is a complex activity, like that for a process also migration is a complex activity, and it involves proper handling of several sub-activities like freezing that process. We should not freeze the process when in the middle of the instruction. Like that, some sub-activities will be there. We need to properly handle it in order to meet the requirements of these process migration mechanisms. So those four sub-activities which are involved in process migration are freezing, transferring the process, forwarding messages, handling the communication. So freezing the process on its source node and restarting it on its destination node. One of the sub-activity means we need to stop execution or suspend the execution and where on source node means originating the, and after transferring we need to restart it on its destination node. Transferring means this process address space should be transferred to the destination node. This is the sub-activity, very important sub-activity. And third, forwarding messages meant for the migrant process. And last, handling communication means when we are replaced on different nodes, this cooperative process communication should be handled. So, what are the different mechanisms for freezing and restarting a process? This is the first step now, freezing and restarting. For this freezing and restarting, what are the different mechanisms are there? Means immediate and delayed blocking of a process. In the name itself, we can know that immediate means when the process is selected as to be migrated, then we can immediately transfer the process, or it can be delayed by blocking of the process. That is immediate and delayed. Before a process can be frozen, its execution must be blocked. So depending upon the current state of the process, it may be blocked immediately, or it can, in some cases it should wait because the process reaches a state. So we should wait in some cases. Whenever any system calls are executing by this process, in such a case also, we should wait. We should not suspend at a time like that. If the process is executing a system call and it is waiting for any event from operating system, in such a case also, we can immediately block the further execution of the process. Like that, we can have some process executing in a system call, or it is in a waiting state or in a sleeping state or waiting for any other resources. Like that, we need to take care, and then we need to block the execution. So it might be immediate or delayed. If we are doing any work, we will ask somebody to wait. Means we are blocking them to complete this job. Like that, before blocking, if we are doing any system calls or any important work, the blocking will be delayed. And the next mechanism is fast and slow IO operations. Means after the process has been blocked, the next step is freezing step. So the process has to wait for the completion of that IO operations which are associated with that particular process. So proper mechanisms are necessary for continuing this slow IO operations, and after the process has started its execution on the destination node, we need to take it. So a process can be frozen after the completion of all fast IO operations, or if it is not feasible to wait for slow IO operations, then we should choose some pipe or terminal in order to convert them after process migration. And the third mechanism is information about open files. This one. A process state information is also consisting with the currently opening of opened files. Means P1 has opened file 1, file 2, file 3, and now it is going away to another destination node. If these files are in open mode only, then those cannot be available for the other process. So, in the process state, we need to take care about the open files, currently opened files, and what are the different access modes of given for that particular file. Like that, all the approaches we need to take care about the information of open files, and reinitiating the process on the destination node. So this one is on the destination node, it will create one empty process state, and it is very much similar to the one which is allocated during the process creation, and same the my identifier for the process is created, and a newly created copy of that process is given and process identifier, and the process migrated will be given access to old copy and new copy of the files at the same time. And the next is address space transfer. In this mechanism, generally a process consists of the program being executed with the program's data, and it will use its stack, and it will have its state. So the process migration will involve the transfer of process state and process address space. Address space, what we will transfer means the code, data, and the stack of the program will be transferred to the new node. What the process states will consist with means the execution of the status. All the registers used for that particular execution, memory tables, IO buffers, all those right to access that file or the process, all those details will be transferred to the destination node. And here we will have a method of freezing while transferring the address space. These freezing mechanisms are of three types: total freezing, pre-transferring, or transfer on interference. Okay. In total freezing method, a process execution is stopped while its address space is being transferred. But in pre-transferring, the address space is transferred while the process is still running on the source node. Means it is not yet freezed, it is in under execution of the code on the source node itself, that is pre-transferring. Address space will be transferred before moving to the destination node, and it is still running on the source node itself, that is pre-transferring. And the other one is transfer on reference. So this method is based on the assumption that process will tend to use only a relative part of the address space while executing. So in this method, the process address spaces will be there on the source node itself, and as the relocated process executes its execution on the destination node, it only references the pages which results in the generation of the requests. So on demand, when this demand driven basis, the copy on reference approach will be there. So like this, on demand transfer of the address space will be there. So address space can be total freezing, transfer, transfer of reference. So those are the mechanisms which are used for freezing or restarting a process. Now, next topic is message forwarding mechanism. So when we are moving a process, we need to know about all the pending process and what are the routing and feature messages which will arrive to that particular process new location. So these messages to be forwarded to the migrated process new location. So all those should not reach the source node. It should reach the destination node as the process is migrated. So we should forward the messages also. So messages received at source node after the process execution can be stopped. And the process execution, if the process execution has not yet been started on its destination node. And the second one is messages received at the source node after the process execution has started on its destination node. Means they are received on the source node after the process execution, so they have to be started again on its destination node. Messages which are sent to the migrant process from any other node and after it has started executing on the destination node. So these are the three messages need to be forwarded for a migrant process to a new location. These three types of messages will be forwarded to the migrant process. So for this purpose, there are different mechanisms. Out of them, the mechanisms for resending the messages is one: origin site mechanism, link traversal mechanism, and link update mechanism. In this origin site mechanism, the process identifier of the systems will have the origin site which is embedded in it, and a process current location can be obtained by consulting this origin site. What this origin site will do, this origin site then forwards the message to the process's current location. If it is another node, then this origin site will forward those messages to the currently executing destination node. So this method is not a good point of reliability because failure of origin site will disrupt the message forwarding. We cannot pass the messages to the another process, to the process which is executing on destination node if this origin site is failed. So this one is not at all a good mechanism for forwarding the messages. And then next mechanism is link traversal mechanism. So to redirect the messages of type 2 and 3 which we have discussed here, the forwarding address is known as link, and it is left at the source node pointing to the destination node of the migrant process. So here this link, this important part of the link will have two components, that is a unique process identifier, and the second one is last known location of the process. So it can forward the messages of type 2 and type 3 as a migrated process is located by a link, and there will be a possibility of forming a chain leading the process to the current location. Via that link will be there from source node to the destination node. And all the components will be obtained periodically. And this link traversal mechanism also suffers from the drawback of poor efficiency and reliability. Means there might be several links for different process migrations, and if any node in the chain of link fails, then the process cannot be located. So another mechanism is link update mechanism. In this method, the process will communicate via location independent links. Means during the transfer phase of the migrant process, the source node will send the link update to the operating system. These link update messages will tell the new address and each link held by the migrant process. So this task is not an expensive task, and the communication requests which are postponed while the migrant process was received, all those will be transferred. So all the type 1, type 2 are forwarded to the destination node by the source node, and third type will be sent directly to the process's destination. And the next is mechanism for handling co-process. So we are here seizing the process mechanisms we have seen, forwarding messages we have seen, transferring the process address space we have seen. So now the mechanisms for handling the communication between the co-process. What are the different mechanisms are there? Those are these two. Disallowing separation of the co-process, and another one is home node or origin node concept. So one of the easiest method of handling communication between co-process is to disallow their separation. So it can be achieved by, we can disallow the migration of the process which will wait for more than one or more children to complete its job, and we can also ensure that when a parent process migrates, its children process will be migrated along with it. So by migrating like that, we can disallow the separation of the cooperative process. And the another one is home node or origin site. So this method allows the complete freedom of the migrating a process, or we can uh, give an independent access to the sub-process which are executing on different nodes. So all the communications between parent process and children process will take place via the home node, and the message traffic which will be there in the systems and the communication cost will increase somewhat in this type of method. And the next concept is process migration in a heterogeneous system. So when process migration in a heterogeneous environment should be taken care when a process is being migrated to such a system. Means the interpretation of data should be consistent on both the source and the destination node, and the data translation, how to translate the data should not arise. When a process is migrated in a heterogeneous environment, all the concerned data must be translated from source CPU format to destination CPU format. Why? Because all the systems will not have the same configuration. They are not homogeneous. They will be of heterogeneous systems in which each processor will have their own configurations, and each CPU cycle is also different. CPU types will have some translation softwares, and they can easily migrate the data. And we need to take care of the serializing, means saving the state of the object, deserializing the object. All the external data representations should be taken care when the process is moving to a heterogeneous system. Handling the exponent or mantissa of that process, all those should be taken care. And what are the advantages of process migration? Next topic is advantages of process migration. So the first advantage to the users is reducing average response time of the process. Means response time is nothing but the time taken from initiating the request to get the reply is nothing but the response time. So whatever time is there, the average response time of the process of a node will rapidly increase. Means when the load on the node increases, the average response time will increase. So process migration facility will reduce this average response time of the process. Why? Because we are migrating the heavy loaded process on a node to a idle processes or the nodes. And the second advantage is, so it reduces the average response time. Still we can get the responses in a less time. Why? Because the migration is there from heavy loaded process to idle nodes they are moving. And the next is speeding up individual jobs. So process migration facility can be used to speed up the individual jobs processing speeds. So the first method to migrate this task is to identify different nodes of the system to execute them concurrently. Means whenever all the processes are executing concurrently, we can speed up all the individual jobs. And the second approach to speed the individual jobs is whatever node having the faster CPU or the node with minimum turnaround time can give the speed in individual jobs. The third advantage is gaining higher throughput. So in a system which does not support process migration is not fully utilized. Means if there is no process migration, then the usage of all the CPUs in our different nodes are not utilized correctly. When there is a process migration, we can use the CPUs of different nodes in 100%. Like that, these different load balancing policies or load sharing policies will give you a higher throughput. And fourth one, utilizing resources effectively. We know that in a distributed system, we have the capability of using different various resources such as all the CPUs or printers, storage devices of different nodes are different, and we can use them whenever we want. So this depending upon the nature of the process, it can be migrated to the most suitable node. Whatever node is having these all resources, if we migrate that process to that particular node, it can effectively run in that particular node. So process migration will facilitate for using of these resources by the process, and it can get the successful running of that particular process on a node. If P1 process is executing an N1 is not having any resources, then P1 process should wait for getting the resources. It cannot execute its job without any resource. If the process is migrated to N5, means P1 is migrated to N5, N5 is having all the resources like a printer or CPU cycles or any hardware devices or any files or database, then it can easily execute its job on N5. So this process migration, with the help of process migration, we can able to use the resources in an effective manner. Why? Because it need not execute only on the originated node. It can move on to, it can migrate to any node and it can execute. And it also reduces the network traffic. So this decreases the cost of accessing the favorite resources, and improving system reliability. Means process migration facility will improve the system reliability in a way that if a process is migrated from a reliability which provides by the system, in such a case also it provides better reliability. Means even in the case of failures or any node crashes or manual shutdown or degradation of the nodes will not be there. If at all if they are in the system, they can be migrated to another node. So they improves the reliability of the system, and it also improves security. For security purpose also, this process migration will help. This is nothing but any sensitive process is there and it is migrated, and we can run it on a secure node which is not accessible by general users. It is not accessible by general users, then it is a somewhat providing security. So improved security of a particular process can be done using process migration. So these are some of the advantages. So in this lecture we have covered what is meant by process migration, why a process needs to be migrated from source node to a destination node, what are the different uh, concepts behind achieving this process migration, different desirable features of a good process migration mechanism we have discussed. For each uh, for each sub-activities of a process migration, that is the freezing of the process, we have seen mechanisms, transferring of address space, forwarding the messages, or even handling the communication between co-process. For all these four sub-activities in a process migration, what are the different mechanisms followed in process migration we have discussed. And at last, what are the advantages of process migration? I hope you all have understood this topic. Thank you.